Okay, so these are the notes that we took today, Monday, February 6th. Please make sure that you have joined my Google Classroom. And then we also have this sheet that tells me my vocabulary words, what I need to know in this unit, what the timeline when you're going to use it, and at the bottom here, 5 ways this topic relates to my everyday life. That is going to be a grade, so please make sure that you start paying attention to how this relates to your everyday life. And if you have any questions, please be sure to write that down here so you can ask me. Okay. All right, so stoichiometry. Stoichiometry, we learned, is the study of the number of particles, grams or liters, used or produced during a chemical reaction. Okay. We have the mole map. We're going to use mole problems to figure out, thanks, I didn't realize it wasn't in there. We're going to use the mole map to figure out our mole problems. So we have 1 mole, and here's a volume, 22.4 liters. Draw Darth Vader's ship, 6.02 times 10 to the 23rd representative particles. And remember, a representative particle is an element, or I'm sorry, an atom, a molecule, or a formula unit. Okay? And then we know we can also find a part of a representative particle by using the subscripts for every 1 representative particle. Then we can find the mass in grams by using the molar mass. Please make sure you have that memorized. Okay, so to solve stoichiometry problems, we're going to, so these are the steps, we're going to get to moles, and we're going to get to moles by working a basic a basic mole problem. Then we're going to use a mole ratio, and then we're going to get to the ask for. So to get to moles is just a basic mole problem, mole conversion. Then our ratio is going to be the unknown over the given. Then we're going to get to our ask for, which again is just a basic mole problem conversion. The mole ratio is going to be the only time where you have moles on top and on bottom. You're going to get the number values for moles in the mole ratio from the coefficients in the chemical reaction. If you are not at the mole ratio, then you should be getting the values from the mole map. Remember, it's always 1 mole. Okay, so we're going to write our, we're going to circle our unknown, underline the given. Number 2, we're going to write the formula and balance it. Okay, and then we're going to write our given and unknown above the formula. Write given and unknown above formulas. I'm sorry, I said write formula, I meant write equation and balance. Okay, so how many moles of aluminum oxide are produced when 0.60 moles of iron 2 oxide reacts with aluminum? So we write iron 2 oxide plus aluminum yields, we know it yields aluminum oxide plus what? Because we got to carry that iron over here. So we got to make sure we bring the iron. This is going to be a single replacement reaction. So I have 2 aluminums, I need 2 aluminums. I have 3 oxygens, and 3 irons. So now I've written that equation and I've balanced it. Now it tells me to write the given and unknown above the formulas. So my unknown is moles of aluminum oxide. So we're going to write a question mark moles. And then we're going to have moles, 0.60 moles of iron 2 oxide. Okay, we always start by writing our given, 0.60 moles of iron oxide. Remember, every number needs a number, a unit, and a formula. So the words on the top are the words on the bottom. Moles of iron oxide. So the first step tells me to get to moles. I'm at moles. The second step tells me mole ratio, which is the unknown divided by the given. So here's my given. So moles of my unknown, aluminum oxide. So I'll look for the balanced chemical equation. I have 3 moles of iron oxide to 1 mole of aluminum oxide. So remember, if we don't have a coefficient here, it's understood as 1. I'm coloring these in so that way you can just see where these numbers are coming from. So 0.3, I'm sorry, not 0.3, 3. So you can see these two go together and those two go together. All right, my third step is get to ask for. My ask for is moles, so I am done. I multiply across the top, divide by the bottom. Now this one we don't even need a calculator for because we know 6 divided by 3 is 2. So we'll have 2.0 times 10 to the minus first moles of aluminum oxide. And that's our final answer. Okay, so let's move on to the next one. How many silver atoms are produced when silver nitrate reacts with 0.025 moles of calcium? So we have silver atoms. Oh, I'm sorry, that's produced, isn't it? Let's see, with silver nitrate reacts, that's why I always try to underline that one twice so I keep up with it, with calcium to produce silver plus calcium nitrate. So we need 2 nitrates here, and we need 2 silvers and 2 silvers, so it's balanced. Step 3 is going to be to write the given and unknown above the formula. So how many silver atoms? Question mark atoms. I can abbreviate atoms as a representative particle, so I'm going to do that for ease. And then 0.025 moles of calcium, 0.025 moles of calcium. Okay, so this is again a single replacement reaction. No, not all of them will be. So I'm going to first start by writing my given, 0.025 moles of calcium. Remember, everyone needs a number, a unit, and a formula. First step is get to moles. I'm at moles. Next step is my mole ratio, unknown divided by the given. So the words on the top are the words on the bottom. This will help me remember what is my given. And it's understood as 1 to 2 moles of silver. Okay, so moles of calcium cancel. And now we're going to do, look for our unknown. So let's make sure we know where these numbers are coming from. When we don't have anything there, it's understood as 1. And then 2 moles of silver. Okay, so help us keep track. Oh, those look very similar. So let's do this one. So you can see that color a little bit better. Okay, so our unknown is silver atom, so I'm not done. The words on the top are the words on the bottom. So for every 1 mole of silver, there is 6.02 times 10 to the 23rd representative particles of silver. We're going to multiply across the top and divide by the bottom. I need 2 sig figs here. So we will have 3.0 times 10 to the 22nd silver atoms, or atoms of silver. Or if you left it at representative particles, that's fine too. Many of you will have gotten 3.01, but I only need 2 sig figs, so that one will be 3.0. On to the next one. How many grams of sodium are needed to react with 18.5 liters of oxygen gas? How many grams of sodium are needed to react with 18.5 liters? So we're going to have sodium reacting with oxygen gas. Remember, that's a Brinkerhoff, and it forms sodium oxide. So this is a synthesis reaction. Okay, so we're going to put our question mark grams, and because that's our unknown, and then this will be 18.5 liters of oxygen. I didn't need that oxygen, did I? Okay, we're going to start by writing our given. 18.5 liters of oxygen. So the first step is get to moles. So I need a mole problem. The words on the top or the words on the bottom. I know that there's 22.4 liters of oxygen for every 1 mole of oxygen. Second step is mole ratio. The words on the top or the words on the bottom. So this will be moles of sodium. Hope I didn't balance the equation, did I? Oh, that will be a 4 actually, because this is a 2 because I need 2 couldn't see. 2 oxygens, so this is actually going to be a 4 here. Okay, so this will be 4 moles of sodium and 1 mole of oxygen. Lastly, we need to get to our unknown. Our unknown is in grams. So the words on the top are the words on the bottom. So 1 mole of sodium is 22.99 grams of sodium. I got this number from the periodic table. All right, we multiply across the top and divide by the bottom, and you get 7.59 times 10 to the first grams of sodium. Okay. So the next one is going to be here. How many grams of nitrogen dioxide will be produced if 5.43 times 10 to the 22nd molecules of oxygen gas react with ammonia? So you're going to set it up just like I told you. Here I had to put the grams underneath because this one ran over. So the words on the top are the words on the bottom. So this is 6.02 times 10 to the 23rd representative particles for every 1 mole of oxygen. Then the words on the top are the words on the bottom. This is our mole ratio. So there are 4 moles of NO2 for every 7 moles of O2. Then we go to the periodic table and find the molar mass. Multiply across the bottom, multiply across the top, and remember to always divide by the denominators. So you'll hit multiply 5.43 times 10 to the 22nd times 4 times 46.01. Hit enter. Divide, divide. Do not hit multiply here. Then our propane is completely combusted at STP, standard temperature and pressure. It forms water vapor and carbon dioxide. That carbon dioxide is how we knew it was complete combustion. What mass of water is formed? So we write out our formula, we balance our formula, then we write our givens above and our unknown. We start by writing the given. The words on the top are the words on the bottom, so this is a basic mole problem. Then the words on the top are the words on the bottom. Here's your mole ratio, unknown divided by given. We know it's our unknown because we put a question mark on it. And then we find the molar mass. Oops, I did not underline and circle. Please make sure you do so. Okay, so that's the lecture for first part of stoichiometry for pre-AP. This homework is due tomorrow. Thank you so much.